Hello everyone, let's see this question. Water is flowing in a tube with a speed of this much, and mm, there is a valve installed and it is closed suddenly. And due to that, there is a sudden rise, which is also known as hydrodynamic shock. So we are asked what should be the minimum thickness of pipe in order to provide a safety factor of 5. Okay, so density of water is given, sound speed is given, and tensile strength is given. So the rise of pressure due to sudden closing of valve is governed by the Joukowski equation. So here I have derived the Joukowski equation. So what we can imagine is that when the valve is closed, you can imagine this like a rigid wall. Now this hydrodynamic shock of the water's momentum stopping, it travels through the fluid with the speed of sound, because that is the speed with which any disturbance in fluid can travel. Okay, so we take a small element of water of length dx. It will have a mass of how much? Rho a dx. So it will have a momentum of how much? Rho a dx into v before stopping. Now in dt time, this momentum is brought to 0. So dividing both sides by dt, you would get the force. Okay. So the dt term we can calculate. We know that the time taken for the hydrodynamic shock to travel through this dx length would be dx by c, where c is the speed of the wave. So we would get that the force is rho a dx upon this dt into v. So we get that pressure is rho into c into v. Okay. Now, due to the tension, what will happen? There will be an inward component. So when the pressure increases suddenly, the tension has to balance that. Okay, the tension from the walls of the tube has to balance that. So the inward component of tension, as we do this calculation in surface tension derivation also, the inward component of tension would be how much? It would be 2t sine d theta by 2, right? Since sine is very small, you can ignore it. So it becomes simply t into d theta. So this inward component of tension must be balanced by the pressure force outwards. So the pressure force outwards is what? Pressure into area. Area will be how much? R d theta will be the width and L is the length. So the area is R d theta into L. Now divide both sides by T into L. On dividing both sides by T into L, we get that the stress in the wall, in the material of the wall, it would be what? PR by T. But we want that there should be a factor of safety of eta. That means what? This PR by T, it shouldn't be equal to the stress. It should be 1 by eta times the maximum stress which the wall can sustain. So for the wall, what will happen? We will get that the thickness is this eta into rho CVR divided by the sigma. Okay, where sigma is the maximum stress. Okay, so this sigma B is given as per the question. So we can calculate this, and this will come out to be near about 1.1 millimeter. Okay.